In this final piece of the historic voice section of this series, I want to take a brief look at the legacy voice components and connectivity. I guess you could look at this as kind of a sum it all up. This is all the pieces of the legacy voice world and how they fit all together. I think this will be great because this will be kind of the bridge as we start moving into where Cisco fits in, voice over IP, because we're going to have to be bridging to this legacy voice world for quite some time to come. We're going to look at the pieces of the PSTN and what comprises the public switch telephone network and puts it all together. We'll look at the difference between PBX and key systems because we have an exact replica model of that in the voice world of Cisco. And then we'll wrap things up by looking at the PSTN numbering plans and the standards that have been created for numbering plans on the PSTN. Well, let's begin by digging into the pieces of the public switch telephone network. What holds it all together? The public switch telephone network is usually represented in all our network diagrams as this cloud, the cloud where all of these connections go into. But if you were to open up the cloud, what you would see is central office switch after central office switch connected together all around the world through these SS7 signaling trunks. Now, in the last nugget, we talked about SS7 as being one of the possible signaling protocols you can use if you're using a CCS style connection where you have a dedicated signaling channel. Now, all of these CO switches are housed in buildings that can vary from little shacks in the side of the road to a metropolitan sky-rise building. One of the first training jobs I ever had was training U.S. West technicians about this up-and-coming technology called DSL, and it was really how to install network cards in people's computers to get ready for DSL and things like that. And we would actually travel around. I actually went up and down the whole west coast of the United States, going in and out of COs, provisioning DSL lines and all that. And some COs, are just dirt. You walk in, you go, wow, how does anything electronic work here? There's cobwebs, there's things like that. Nobody actually works in the CO. It's just a building that's there for the small neighborhood. And then we'll go into some areas that, maybe a downtown area where you're literally going up through 3 floors of clean wiring infrastructure, many people on staff, security guards, elevators. Because that is the central office for it happened to be the entire Minneapolis downtown area that I was in that CO. And so all these different COs have all these trunks connecting them to provide connections for all the incoming and outgoing phone lines. Now, the larger the CO, the more trunks they'll have outgoing and incoming for its connections. Now, on the analog side, you have this local loop that runs out of the CO switch through the whole neighborhood and ends up connecting into the various houses that are there. That plugs into our analog telephones at the other end. Now, even that is changing because carriers are running fiber optic cabling everywhere. So instead of being copper cabling looped around, we're now seeing fiber optic cabling that is going around, and then they have these things known as now I'm thinking cable modem networks, but they have hybrid fiber coaxial connectors where it converts fiber to a coax connection, or they have hybrid fiber to copper connectors where you can come into a normal telephone line, which then supports an analog signal. So there's all kinds of ways that we're able to connect to the end user. Now, we come across to the other side and we can have trunks going into businesses. Now, instead of running a ton of analog connection, we can then use a digital trunk, which is using either CAS or CCS signaling, depending on what the carrier supports or what the end user chooses. They are able to support on their PBX system. That comes into a private switch inside of the office, which could be either categorized as a private branch exchange or PBX system, or it could be a key switch. And those end up going down to digital telephones. Notice we're now in the digital realm rather than the analog world of signaling, since we can have digital to the desktop, where ones and zeros are coming out of the phones into the digital private switch, which continues on ones and zeros through the trunk. We essentially have no analog signaling end-to-end by using these PBX systems. These digital handsets are proprietary in nature in the legacy world, to where they had to be linked to, if this was an Avaya PBX, this was an Avaya phone that would support the digital signaling back and forth. So let's focus into the offices now, the business offices that have the PBX and key systems. These are two different devices that are designed to let a business run their own little miniature public switch telephone network inside of their office. Essentially, they can have less incoming lines than they have telephones for. So the idea behind it is fairly simple. They plan that the people sitting at their desk are not all going to make an outgoing call to the PSTN at once. So why buy a PSTN line for every single desk extension that they have? Instead, we'll have an internal managed system where people can place calls to and from their own phones in the offices without having to use an outside PSTN line. They can just go through that PBX system, and if they need an outside line, then they can go out to the PSTN that way. So that's the idea behind having a PBX or key system. Now, what is the difference? Well, when I talk about the differences, these are all generalities because PBXs and key systems have advanced in such a way that key systems are the newer ones and the more modern ones are more like PBXs than most people may think, and that just becomes caused by pressure in the sense that, competitor A comes out with a new feature for their PBX, so competitor B is like, oh, well, I'm coming out with a new feature for my key system that competes with that, and, blah, blah, blah. So the key systems have grown quite a bit larger, but were originally designed to be smaller. So a PBX system, when you think of a PBX, they typically have digital PSTN connections. So this is where you have your incoming T1 and E1 lines, typically. They provide each user a unique extension to where I would have extension 2001, 2002, and so on all around the office, and will typically support a large number of features that people have come to know and love inside of their PBX systems and inside of businesses, like conference calling, like hold music on hold, throw out the laundry list of features there, and PBXs probably support it. Key systems, on the other hand, are usually a smaller scale. They're for a small office. You've got 10, 20 people in your office. You don't need a giant forklift-size PBX system. A key system usually hangs on a wall. It's smaller, and it supports analog PSTN connections. So maybe you have 3 analog lines in for your 10-person office to where you don't expect any more than 3 incoming or outgoing calls at a time. Again, these are typical because there are key systems that also support digital connections. They use typically shared lines between phones. So this is where you'll see the phone that has extension 2001, 2002, and 2003 all on the same phone. You go to the next phone, and it also has 2001, 2002, 2003. Matter of fact, most of the time, you may not even see extensions. They'll have line 1, line 2, and line 3, which doesn't really have a specific number. These are just the same 3 shared lines that are all on all the different phones that match the 3 analog lines that you have coming in to that key system. So if you hit line 1, you are actively using the outside analog line at a time. Some key systems don't even allow you to call between the phones on the key system, since they all just have lines, and they're assuming your office is small enough where you would just yell, "Hey, Bob," because he's just across the hall from you. So there really wasn't any need for internet office calling in that kind of environment. If you put a call on hold on line 1, you could yell to the other person, "Hey, Jane, you got a call on line 1. Go ahead and pick that up." And she could pick it up over on her phone because they all have the same 3 lines. Typically, these key systems also support a smaller number of features than PBXs. You won't get a lot of the advanced like call center features and things like that because it's just a small scale device. In order to manage the chaos of the PSTN, there had to be some kind of standard for dialing numbers. That's the idea behind a PSTN numbering plan. Imagine if there were no standard, someone in some country could just say, well, I just want to make my numbers 4 digits long. So if you dial 4111 from anywhere in the world, that'll map to me. And then you have all of these chaotic systems of, that overlaps with this, and that's taking precedence over that, and all of these different things. So the ITU, the International Telecommunication Union, created this standard known as E.164. E164 is essentially the recommendation for how to organize numbers to be a standard on the PSTN. Now, if you really dive into E164, you can get pretty complex into all the different standards that are created. Like, I'll take you right now to our good friend Wikipedia, and if you scroll down on Wikipedia's E164 page, I just scrunch this down a little, you'll see structures for geographical areas, global services, networks, groups of countries, and then you start getting into all the substandards of E164. There's many different ones, and that's just a high-level overview for E164. But really, the primary standard that's used is the global standard, which defines that you will need a country code, a national destination code, and a subscriber number. Now, each number that is E164 compliant is only a maximum of 15 digits in length. So regardless of how many digits you have for this, or this, you need to make sure that it is always under 15 digits. So if we look at the North American Numbering Plan, or NANP, our numbering plan defines a country code, that's our 1, an area code, which is 480, a central office code, which says what central office you belong to, that's this 3-digit number right here, and then there is a station code, which is the last 4 digits right there. That defines what station you are in that central office. Now initially you might look at that and go, well, seems like we've got our own numbering plan in North America compared to the E164, but really it boils down to the idea of having this being your country code. United States is country 1. This being the national destination code, and then this being the subscriber number that falls into the E164 standard. So countries can create their own little standards of however they want to organize their number, as long as it breaks, you can break those numbers down into the specific 3 areas that are required by E164 so you can participate on the PSTN. Well, I promised it'd be short, but that wraps up our section on historic voice by looking at the legacy voice components and connectivity. You saw the pieces of the PSTN, which include the central office switches, the SS7 protocol going between them. We had the trunks going to the businesses that could house either a key system or a PBX, and they have their digital phones. Or you had the local loop that runs through neighborhoods that analog devices connect to and use analog signaling into the PSTN central office. We looked at the difference between PBX and key systems, which nowadays is almost historic because key systems have begun to support so many features. But essentially, key systems were smaller, typically supported analog trunks, and used shared lines between everybody. Whereas PBX systems were larger and supported digital trunks, and everybody had their own unique extension. We finally looked at PSTN numbering plans, which fall under the E164 standard. Every country has their own numbering plan, but if it's going to work on the PSTN, it has to subscribe to those 3 major categories that the number breaks down into. I hope this has been informative for you, and I'd like to thank you for viewing.